Let's do a final multiple body problem. This time we have a pulley with a couple of masses. One mass is on the table, the other mass is hanging off of the pulley. And once again, we are going to assume that the tension is uniform throughout this rope, unless we're told otherwise. And this rope is going to slide without friction over the pulley. So once again, this pulley is not going to be rotating. It's just meant to change the direction of that rope. If that pulley is going to rotate, then we need to be told things like, what's the mass of the pulley? What's its radius? Or what's its moment of inertia or something? Those are topics for later on. We're starting with the simplest cases here at the beginning, and then we'll add to those as our understanding improves. So we want to determine the acceleration of the system and the tension in the rope. All right, let's say that the system is all of this. If the system is the whole thing, what's the net force on this system? If this whole thing is the system, the tension cannot be considered because the tension is an internal force. So we're not going to be able to find tension if we are considering the whole thing as the system. The net force is going to equal the mass times the acceleration. And what's the net force on this system? Isn't it just the weight of this 2 kilogram mass, which is 20 newtons? And the mass is 3 plus 2 is 5. So the acceleration of this system is 4 meters per second squared. Usually when you want to find the acceleration, you want to have your system be the whole bit of it. That's usually what happens when you're finding the acceleration. Now, to find the tension, you cannot have the system be the whole thing. You have to break up the situation into this part of the system or that part of the system. So let's say that the system now is the 3 kilogram mass. And let's draw a free body diagram of that. No, you know what? Let's just take it shorter. Does Newton's second law apply to that system? Heck yes. Newton's second law applies to everything. What's the net force on this 3 kilogram mass? Well, the weight and the normal force cancel each other. There's no friction. So the net force is just the tension to the right. Well, that has to equal the mass of the object, which is 3, times the acceleration. Hey, the acceleration is 4. So the tension in the rope has to be 12 newtons, 3 times 4. You know what? We've got time. Let's suppose, instead of choosing the system as the 3 kilogram mass, suppose you had chosen the system instead to be the 2 kilogram mass. Let's say we don't know what the tension is and we're trying to find it. What would the free body diagram of that system look like? Let me draw it over here. We'd have mg down, which is 20 newtons, right? 2 times 10. And then the tension would be trying to hold this mass back. The tension is pulling this 3 kilogram mass to the right, but it's trying to hold back, unsuccessfully, the motion downward of this 2 kilogram mass. So the net force on the 2 kilogram mass, ready, is 20 minus t. That's the net force. And that needs to equal the mass of the object times its acceleration. Now, way back when we were young, we figured out that the acceleration here was 4. 20 minus what equals 8? Oh, look at that. You see, you can get that tension either considering this as the system or considering that as the system. Doesn't make any difference. You still get the same answer. That's pretty neat.